At the heart of Zerto's replication technology is the Zerto Virtual Replication Appliance, or VRA. The VRAs are the workhorses that continuously replicate data from user-selected virtual machines. The VRAs capture and copy the I/O, compresses it, and sends it to the target site over WAN links. The VRA is a custom 64-bit Debian version of Linux and a 300 megabit OVF. It's designed with increased security and a small footprint in terms of disk, memory, and CPU requirements. The VRA creates a very small amount of overhead on the ESXi host, just 3 to 5% overall. Because replication is done without a snapshot or change block tracking mechanism, there's no negative impact on application performance. The VRA is deployed through the Zerto Virtual Manager and installs alongside the virtual machines already on your host. Zerto recommends installing a VRA on each host in a cluster that is being protected and on each host at the recovery or peer site. VRAs on different hosts communicate between themselves, synchronizing replication to ensure block-level consistency between different VMs located on different hosts and storage arrays. If vMotioning with vSphere or doing a live migration with Hyper-V, having VRAs on every host ensures there is no disruption if one host's performance is flagging or it goes down entirely. Exact requirements for VRA installation differ depending on your hypervisor, but a typical VRA will use one vCPU, 3 GB of RAM, and about 12 to 13 GB of storage space. Let's take a look at the processor, memory, and networking of the VRAs on the source and target sites. The VRA CPU handles I/O processing, disk operations, and replication optimization, which includes compression. The VRA on the source side handles compression, while the VRA on the target side handles decompression. While one vCPU is generally enough, you can have up to 2 vCPUs on a VRA. However, the only time adding an additional vCPU may be useful is if you're not seeing the compression levels that you want. In this specific case, adding another vCPU can help offload compression. The RAM handles the buffer space on both the source and target sites. Zerto's replication takes place in memory of the VRA itself, and this is where the buffer for replication occurs. RAM contains the buffer pool plus 550 to 950 megabytes reserved for the OS. On the source side, buffer space helps with the bandwidth because your disk is typically going to be faster or as fast as the bandwidth between the sites. On the DR side, the buffer space is typically used because you may be replicating as fast or faster than the target disk is writing the data down. If a buffer becomes full, a bitmap sync is performed after space is freed up in the buffer. A sizing matrix is available in the technical documentation section of the MyZerto website. This gives recommendations on buffer space based on the total number of VMs. The NICs handle the traffic throttling. It's important to note that bandwidth throttling with Zerto is egress only or outbound only. Your bandwidth throttling is always done at the source sites. There is only one NIC per VRA. The bandwidth limitations of a VRA depend on the vNIC capabilities. The journal or replica disks are only on the target site. The target site's VRA site has an OS disk, an application and drivers disk, and an I/O logging disk. The sum of these disks is about 12.2 gigs.